Welcome to all of you for my threads and multi-threading topic. Before starting threads and multi-threading and threads, this topic purely belongs to programming. That we do it in Java programming language. But before starting threads and multi-threading, I would like to give you an overview on three runtime environments we are having. The three runtime environments are, one is our programs, like our Java programs, running on command prompt, Java space, our class name. Our programs always runs on command prompt. On the command prompt, what will start is, on the command prompt, the Java virtual machine starts. When we type Java, and then space, if we give any class name, then the Java virtual machine will start. JVM will start. Into that, this class will be loaded. Our Java class will be loaded. So our classes runs in the JVM. In that Java virtual machine level, we'll run threads. In that JVM level, we'll create and start threads. Then they'll start running. So this is completely controlled by our program. Through Java program, we'll control this we'll control through program. We completely control it through program. Java program. Threads runs inside the JVM. And inside the JVM, our program will run. Inside the program, we'll start threads. And where JVM runs as one of the tasks of the operating system. We run so many number of tasks on our task manager. Like Notepad will start. We'll draw something on MS Paint. Now we opened a PPT. Sometimes we'll browse through internet, through browser. And then next we'll open Word document also for some reference. And we play movies as well. Otherwise we listen songs parallelly while reading or preparing a material, less often. So we open multiple programs on our operating system. So we call all of them as tasks at OS level. That is what we call task manager. When you press Ctrl or delete, you get a task manager that shows Notepad is open. The Google Chrome browser is open. MS Paint is open. PowerPoint is open. MS Word document is open. Like that will show. And there are both background and foreground, both processes exist. Background process, a different Oracle process is running, Tomcat process is running, MySQL process is running, some other file process is running, index process is running. It shows some remote system connectivity process running, like that. Some background processes. Foreground processes these are the processes which I talked about. At OS level, we talk all of them as tasks. Where this OS will run inside the processor. In the processor, operating system will run as a process. Hence, we divide it. Though actually our topic belongs to thread and multi-threading, I want to give a 2-minute from my knowledge point of view. I would like to give a brief introduction about what is process, what is task, and what is thread. These three. So processes runs at processor level, tasks runs at operating system level, threads runs at JVM level. And in the program we'll write, and those programs will run inside the JVM. So JVM level threads, OS level tasks, process level processes. So this is just about a brief note on what is process. when an operating system runs in a processor, single processor, it can run multiple tasks such as Notepad, IE, MS Word, Windows Explorer, command prompt, etc. in simultaneous manner. And here one thing you must observe, whether it may be a task or a thread or a process, whatever we parallelly open, they all not runs in a parallel manner. They all runs in a simultaneous manner. So for that, various models will be used at operating system level and JVM level to run multiple of all this. Because of single processor embedded in single chip, runs on only one task at a time. That is an operating system. In operating system, multiple tasks run simultaneously. In operating system, multiple tasks run simultaneously. Notepad, Word document, Internet Explorer, Windows Explorer, Chrome browser, then MS Paint, then some video player or audio player. Again, control will come to first task, again, second, third, fourth, fifth. The tasks, multiple tasks running in the operating system may run in different models. Sometimes the tasks may run in round-robin model, sometimes weight-based model, sometimes priority-based model. So round-robin model means whichever task you start first, second, third, so on, they all will run in that order only. In the weight-based processor, whichever tasks are having more weight, the less tasks process will run faster than the heavy-based tasks. And coming to the priority-based, while running the task itself, we can give first priority to this task, second last priority to this task, some medium priority to this task. Based on the priority also, the tasks will run in the operating system. If you press Ctrl-Shift-O, the task manager will open and all the foreground running tasks will be shown in the task manager. So in the recent operating systems, if you right click on any one of the tasks and say, I want to give low priority or medium priority, high priority, or you want to stop the task, you can choose from there. But you can't suspend the task or you can resume the task, but you can change the priority of the task. Based on that, based on the priority also, the task which is given high priority will execute more time. The task which is given low priority will take less number of, the processing life cycles to run. So based on that, you can feel the difference between, whether the task is running faster or slower. This is how we call operating system as a multitask operating system. If single integrated chip consisting of multiple processors, then operating system runs on multiple tasks and multiple processes running in a single chip. This is called as multiprocessor. Anyway, I don't want to talk about operating system much. So, this is all related to that. But anyway, coming to the process or task, when we compare with thread, the one main difference between the task, process and thread is thread we will write, programmer will write, thread programmer will write. Thread programmer will write, thread runs on JVM, runs in JVM. Threads can be controlled via API. Threads can be controlled via API. And through application programming interface, we can control the threads. We can start the thread. We can suspend the thread. We can resume the thread. We can stop the thread. We can give low priority to the thread. We can give high priority to the thread. So, unlike tasks and processes, threads from the program, we can control their execution, their flow of execution. So we'll see that in the programming. So when a command prompt is opened, and on the command prompt when we run Java command, it is one task of the operating system. The Java command runs JVM that loads our Java program, and from that single program when we run multiple jobs, then they are called as multiple threads. I'll give more detail about on what basis we need to choose the thread, that we will discuss in the next slide. It means threads are subset of tasks and tasks are subsets of processes. Tasks are uncontrollable flow of execution because we can start and stop the task execution, but we cannot suspend them or sleep them or resume them for a while about the task. Coming to the threads, whereas when threads are started using Java Threads API, we can start the thread, we can sleep the thread, we can suspend the thread, we can wait the thread execution, we can resume the thread execution. This is how we can control the threads flow of execution in a Java program. So coming to the threads, I generally talk about the threads in three different models of execution: sequential execution, simultaneous execution, and synchronous execution. Triple S model: sequential model, simultaneous model, and synchronous model. I have a question. As a Java programmer, if you are asked to write thread, as a Java programmer, if you are asked to write a thread, or if as a Java programmer you are asked to write multi-threading model for your application's execution. So as a programmer, how do you determine that how many number of threads are required in the Java program? That is very, very important. Writing thread is not a big deal. There are some API available to extend from class or implement from some interface, and we can implement the methods. So thread implementation is not a big job because it's a simple API given in Java, using which we can develop, start and execute the threads. We can control the threads. But on what basis we determine how many number of threads are required in our program? That is very, very important. So to understand that, first of all, we need to discuss about sequential method execution. Sequential. Our all method executions are sequential method executions. For example, we are having class A. Class A with two methods, method 1 and method 2. Class A is having method 1 and method 2. Method 1 and method 2 we are taking only just for showing the threads execution. Okay, this is the context before threads. So in the method 1, I'm printing system.out.println, method 1 value so and so, just something like 1 or something. Okay, and what internally I'm doing in the method is I'm taking one try block, and then whenever the method 1 is called, this value will be printed. Simple. System.out.println method 1 value is so and so. If you pass 1, 1 will be printed, 2, 2 will be printed, 3, 3 will be printed. Otherwise, if you put this method in for loop for 100 times and execute, 1, 2, 3, 4, 5, 6, 100 will be executed by method 1. So, whatever you pass in integer value pass into method, system.out.println will simply print that message, and then method 1 will print only that message. But in a method, we are explicitly writing one try block. In the method, we are explicitly writing one try block. And handling, and why we are writing try block? Because in thread API, in thread class, there is one method given called sleep. And if at all, if you want to finitely interrupt, and if you want to interrupt a method execution for a finite period of time means fixed amount of time. Say for example, 100 milliseconds. 1000 milliseconds is equal to 1 second. 100 milliseconds is equal to 1/10 of the second. 10,000 milliseconds is equal to 10 seconds. Like that you calculate. Like that, according to that, you calculate for 1 minute or 1 hour or 10 hours like that. So 10,000 is equal to 1 millisecond. Like that you calculate. Into 60 milliseconds, 1 second. Into 60 seconds, 1 minute. Into like that you continuously multiply to get number of hours, minutes, seconds also. So here I am sleeping the thread for 1/10 of the second. Whenever the method executes, this method explicitly makes the sleep method doesn't sleep the method. The sleep method sleeps whichever thread is calling this method, whichever thread is running this method. That thread will be slept for 100 milliseconds or 1/10 of the second. After, whenever you write thread.sleep, because it is interrupting the method execution, soon after, lot of Java developers feel like, because thread.sleep is sleeping the method execution for a given amount of time, so it is interrupting the method execution. That is why we are handling with interrupted exception. That is absolutely wrong. Why interrupted exception is because of this thread dot sleep, the method execution got delayed. Method execution or its corresponding thread execution got delayed for 1/10 of the second. That is true. After that 100 milliseconds, the program execution, the method execution should continue, or thread execution should continue, isn't it? Even after the sleep at a elapsed time, sleep to completion time, if the thread or method execution doesn't restart, or if it doesn't resume, the method execution doesn't resume. If the interruption continues, then interrupted exception comes. And the interrupted exception comes if thread cannot be resumed after the given amount of time. Not because of thread dot sleep, the method execution is delayed for a given amount of time, the interrupted exception comes. Absolutely no. Sleep method never cause interrupted exception. Once if sleep method execution doesn't resume back from its interruption time, then interrupted exception will come. Similarly, IO exception also. Not when you're reading, IO exception comes. When you're reading, system.in.read will read from the standard input. After reading, if the system.in.read could not resume the program execution from that read operation, then IO exception will come. Input output exception will come. So this is how method 1 is. Similarly, we are calling one more method. We are writing one more method 2. In that also, if we pass any integer value, that value will be printed. And 2 methods are written. Both methods are doing the same thing. Method 1 value is something, method 2 value is something, it will print. But every time during method 1 execution, it is getting delayed for 100 milliseconds. See the client program. There is no thread concept here. There is no thread concept here. To understand the thread concept, we need to understand sequential method execution. We wrote one client program, A client 1, with a public static void main. We created object of class A. A is equal to new AF. A class object is created. The what we are doing? Here we took one for loop. Here we took one for loop. Here we took one for loop from iteration from 0 to less than 50. And there are 50 iterations. We are iterating for 50 iterations. 50 iterations. We are iterating for 50 iterations. We are iterating for 50 iterations. In these 50 iterations, we are calling A dot method 1 of I value. And every time I value 0, 1, 2, 3, 4, 5, 6 up to less than 50 means 49. 0 to 49 values will go. And this method will iterate for 50 times. Which method? Method 1. Method 1 executes for 50 times. Method 2 executes for 50 times. This is what these two for loops does. But one thing we need to observe, here method 1 is called for 50 times. Each time during the method execution, method 1 is getting delayed for 100 milliseconds. Before that time, method 1 cannot continue its execution because we have explicitly written thread.sleep to wait minimum for 100 milliseconds. And 50 iterations plus 50 times into 100 milliseconds. Imagine. That much time method 1 will take to complete all its iterations, and then the second method execution starts. So how much time method 2 is waiting until its method 1 execution is completed? Though in method 1's interrupted execution, even in that time also, method 2 couldn't execute even for a single time. The method 2 execution got delayed because of method 1's execution. Method 1 iterates continuously 50 times and prints its message SOP statement for 50 times. No doubt, no issue. Method 2 will wait until the time method 1 execution is completed. Method 2 will execute. But even including the interruption time of the method 1 also, method 2 is still waiting for the method 1 to complete its all 50 iterations. It is a waste of time to the method. And point number 2, method 2 is waiting, including the interruption time of the method 1. That is one point. Point number 2 is, we always think like this. Is method 1 and method 2. Even then method 2 waits for the method 1 execution. Even method 2 waits for the method 1 to complete all its executions to start its execution. I want to ask you one question. Is method 2 and method 1 are independent or dependent? is method 2 and method 1 are they independent or dependent? If method 2 execution is purely dependent on method 1 to complete its execution, there is no issue. Method 2 will wait until the method 1's it's all iterations. If method 2 is independent of method 1's, even 1 iteration to 50 iterations or as many iterations. If method 2 is completely independent of method 1, then why method 2 should wait for the method 1 to complete its execution? If method 1 gets delayed, if the delay time can be adjusted to method 2, in each of its execution delay of 100 milliseconds, method 2 could complete at least 10 or 20 or 30 or even sometimes it's all 50 iterations also. Like that 48 to 49 more methods can execute within the delay time of the method 1. The why method 2 should wait until including all the delay iterations of method 1. That is a big challenge. In the sequential method execution, there is a big challenge. If method 1 is continuously executing without interruption, okay, method 2 will wait. If method 2 is independent of method 1, not dependent of method 1, but still it is waiting for method 1 executions and its delays also. This is a big thing. Like not only method 2, there are so many other methods which are executing followed by method 1. They're all waiting for method 1 to complete its execution. That is a big challenging thing. Most of the Java applications are intended for simultaneous execution, and most of the Java applications are server-side programming, like servlets, JSP, RMA, CORBA, EJV, web services, microservices. Most of the service-oriented architecture applications. Most of the struts you take, Hibernate you take, Spring you take, JSF you take, WebWork you take, lot of, in Java stripes, Wicket. In Java, so many Sun microsystem given J2E based applications, server-side applications, and as well as so many third-party applications. They're all server-side running applications. In the server-side running applications, no one method will wait for the other methods to complete its execution. Each method wants to run simultaneously, independent of each other. One simple example is, if you take server-side programming like any servlet, a registration servlet. There is a registration servlet. Tomorrow we are having an exam. We asked students at 10 o'clock to complete, around 1,000 students are there. At 10 o'clock we asked students to complete the registrations by 12 noon. Within 2 hours, if all 1,000 students who have registered for the exam, they'll get a tomorrow exam by 10 or 11 o'clock. That's a special exam that we suddenly announced. Within 2 hours time, we want to accept all the 1,000 student registrations. Afternoon, we want to prepare a examination, something related stuff from the afternoon onwards up to 4 o'clock or 5 o'clock. We want to prepare different question papers. So we want to allot them different rooms or systems. Like remaining schedule, we want to do that. So we want to complete the registration process within 2 hours. All 1,000 students connected to a server-side program servlet. Each servlet will process first client request. Once it is completed, second client request, then third, then fourth. If that is the case, by 12 o'clock, hardly not even 100 student registrations are completed. Instead, for each client, if servlet creates, and for each student, if servlet creates one thread and runs the servlet object in all these threads, there is no maximum limit for the number of threads to execute. Whichever thread completes its execution, that thread will exit. Remaining new threads will start. The existing threads will destroy. In the meanwhile, new threads will come up within 2 hours. The maximum number of student registrations could be completed without each thread waiting for the other thread or other student registration process to complete. This is how most of the server-side applications are. Most of the server-side applications want to run one independent of other thread. Now, coming to the threading, tell me, This is completely sequential method execution. Sequential method execution. Due to sequential method execution, there is a delay of one method to complete its prior method to complete its execution. That we want to eliminate. So what to do? So you tell me, in Java application, how many number of threads are required? So in my knowledge, from my experience, I can tell you, as many methods of a class. What? As many methods of a class. As many methods of a class. As many methods. One thread per method. One thread per method. One thread per method means as many. That's what I'm saying. Not as many number of methods. Class consists of those many methods. Suppose if class contains 100 methods, we don't write 100 threads. As many methods of class want to run simultaneously. Want to run simultaneously. Those many threads. As many methods of class want to run simultaneously, we need to determine, we need to write those many number of threads. One thread for each method, not one method for each thread. One thread for each method. One thread for each method. Like that, as many methods want to run simultaneously, those many threads. That is the point. Now, as a developer, it is now clear, comparing sequential method execution with the why we need multi-threading. One method for each thread, methods those who want to run simultaneously. Though method 1 gets delayed, method 2 and up to method 50 or 100 do not want to wait for this method 1 to complete its execution. These methods want to run as much time as given to these methods, as much time these methods can run. Within that much time, all the methods will complete their execution. For that, the methods cannot run as a threads on their own. The point here is, methods can run sequentially, but methods cannot run simultaneously on their own. That is the point. That is why for each method, we need to write one thread class. So how to write thread then? In Java, we can write thread in 3 ways. One is by extending from thread class. We know in Java, we are having 2 types of classes. Class and interface. Class and interface. If you want to inherit from class, you need to call extends keyword. You need to write extends keyword. If you want to inherit from class, you need to write extends thread. If you want to implement from interface, we must use a keyword called implements runner. Extends thread and implements runner. So, by either extending from thread class or by implementing from runnable interface, you can write one thread class. How to run, that we'll discuss later. And third one is by writing an anonymous class. Anonymous class we already discussed in the OOPS topic last. The last topic in OOPS we discussed anonymous class. Without extending from thread class, without implementing from runnable interface. Directly by instantiating runnable interface. In the runnable interface instantiation body itself, we will write thread implementation. This is another type of thread implementation. Most of the applications, those who don't want to write thread as a separate class, they'll implement threads as an anonymous classes in most of the applications. And if thread class do not want to be written separately, and if you don't want to write an external one separate subclass of thread, instantly if you want to implement thread, we can go for anonymous class. Okay, anyway, we'll see the thread lifecycle class in this. Coming to the thread lifecycle, I can better explain after completion of 1 or 2 programs, because thread lifecycle can be better explained after explaining 1 or 2 programs. Then I can come to this. And how to create a new thread, how to start thread, how thread goes to runnable state, how thread comes to end state. All that we can explain after completion of at least 1 program. new thread state. Whenever new thread is created, new my thread, like that, one new thread class object is created, that is a new thread state. As soon as we create thread object, we'll call t1.start, then thread will start. That is called a start method. Start method. Immediately thread will go to run method, that is called as run state. Public void run method. Whenever thread is in the run method execution, it is in runnable state. From any point of view, if you call in the run method, if you call thread.sleep or set t1 dot some suspend or wait or something, from the outside the thread, if you suspend or wait the thread execution, then thread will go to block state. From there it will come back to the execution state. From the block state it will come back to the execution state. Once execution is completed, thread will go to dead state. But this diagram can be better explained if you at least if I could complete one example. Otherwise we don't know how to create thread and how to start thread, how run method is, how runnable state is, all that we don't know. So anyway, this is example number 1. In this example number 1, and this is not example number 1, this is example number 1. Here I am showing how we can create threads in different ways. You can create a class that extends from thread. Class generate thread extends thread. This is one way of implementing the thread. One is extending by thread class and override run method. Here you write thread logic. This is one way. And second way is if you want to write thread in another way, you can write a class that implements some runnable interface. Implement run method. Here you write the thread logic. This is second. Third way is you create object of runnable. This is what called as anonymous class. This entire course. You create object of the runnable. In that you write run method. Here you write thread simultaneous logic, execution logic. And I'm sorry, here start method. I'm sorry. Start method will start the thread execution. Start. So these are the 3 ways to write the threads. We'll start with the first one. So before writing threads, we must have to have a class which has multiple methods. Before writing threads, we must have to have a class with multiple methods. The methods those who want to run simultaneously. Such a class, such a methods we need. First of all. So for that case, we have written one class called a number generator. This is most commonly seen class in every multithreading example. You can take many other classes, like others also. I am also taking one number generator class, a simple class. Number generator class. In this number generator class, I implemented 2 methods called one is generate method and another one is print method. So what generate method is doing? Generate method is printing, generate method executed. What print method is doing? Print method executed. That's only 2 statements. 2 methods, each method with one statement. 2 statements. So number generator class is having generate and print 2 methods. So each method is printing one statement. Now, how many threads are required? For generate method, 1 thread is required. For print method, 1 method is required. Because these 2 methods are independent methods. We want to run them simultaneously. Then how to do? For generate method, how to write thread? Then you write a class called public class generate thread. Public class generate thread extends thread class. Extends thread class. Generate thread extends thread class. So whenever you are implementing thread, in thread we must implement one method called run. That run method written in one thread class. The one run method written in one thread class with other thread class run methods. All run methods will run simultaneously. The run methods runs inside. Where it will run, I'll explain you. Run method implemented in one thread class will run simultaneously with other thread class run methods. who runs that run method, that I'll explain you. How the run method execution starts, so that I'll explain in the client program. So whenever you are implementing thread, you must do two things. One is you write a class that extends from thread, and second one is you override run method. Because in thread class already run method is implemented once, you override it. And from the run method, what we want to do? From the run method, we want to call generate method for 50 times or 100 times. From the run method, we want to call the generate method or run method for 50 times or 100 times. That means, to this run method of this class, which object is called to call generate method? Generate method is a method of number generator class. That means, this generate thread class run method requires number generator class object. So for that, what we can do? In generate thread class, you can directly write number generator ng is equal to new number generator. Whenever you want object of any class, you can directly create object like this. Simple. You create one new object of number generator and call number generator dot generate. Same thing you do it in print thread also. In print thread also, you extend from thread class. In the run method, you override run method. In the run method, you call print method for 100 times. To call print method for 100 times, you need number generator class object. Here also you create one number generator class object. New number generator. Okay, wherever we want a number generator class object, in every class you create number generator class object. The number of number generator class object creations increases more. More number of number generator class objects are created, which will consume more space. I don't know how much space number generator class takes. As many class instance variables as class is having, as many non-static methods class is having, that much memory will consume. You cannot predict how much space each object requires. But creating one class object in each thread for the number generator class occupies more memory. Why? After all, you are creating new object for the sake of calling generate method here and to call the print method here. For that, you are wasting two objects. Instead of wasting two objects of number generator class in two threads, can't these both generate thread class and print thread class? Can't this generate thread class and print thread class? Can't this generate thread class and print thread class can share single number generator class object? Can you do it? So if you want to do it, leave both the thread programs and come to the client. In the client, you clearly observe. In the client, what I am doing, in the client, I am creating number generator class object. One object. One number generator class object I created. That number generator class object I passed as argument into generate thread class constructor and as well as in print thread class constructor. You tell me, passing objects as arguments into method, is this called as pass by value or pass by reference? So pass by reference, right? Only primitive members if passed as arguments into method, then they are called as pass by value. If any object class object references are arrays passed as arguments into methods, then they are called as pass by references. So here I created single number generator class object, and that object is passed as argument into generate thread class constructor and the print thread class constructor. So once if generate thread class constructor passed with number generator object and print thread class constructor passed with number generator class object, if constructors are passed with any object as argument, the constructor must be of the same type, must be passed with as a parameter. If number generator object is passed as argument, both these class constructors must be returned with the number generator class as a parameter. Here also, in the print thread also, number generator class object as a parameter. Then now both generate thread class constructor and print thread class constructors must be passed with the number generator class type as a parameter. Then only into these two constructors we can pass number generator object. This is the advantage of pass by reference. So now you tell me how many number of number generator class objects are created? Only one. But in how many thread classes or in how many other objects that object number generator object is used? So this is how the memory required for the number generator class object, the number of objects will reduce to only 1. Even if number generator class is having 10 methods, if all the 10 methods want to run simultaneously, you write 10 thread classes. But into all the thread classes, you pass same number generator class object into every class constructor and start all the threads. Single number generator object used by all the threads. So then, actually, in the each thread class run method, we are calling generate method and print method. And one more very important point here, I would like to explain this. How many number of threads we are writing? How many number of threads we are writing? We are writing in a class as many, not in one class, in any number of classes. In our application, as many number of methods want to run simultaneously, those many threads we have to write. Those many threads we want to write, isn't it? Correct. But remember one thing, most of the others or students or faculties I observe, directly in the run method, they are going to implement the thread logic, that simultaneous logic, which is absolutely wrong. Yeah, I don't want to point somebody's implementation as wrong, but if at all if you find any logic directly implemented in the run method, you assume that run method implementation is wrong, because run method is the method from which one method, run method in another thread class is a method from which another method are all being called simultaneously. Now run method should provide only a host method to call different methods of different classes who want to run simultaneously, but the thread logic should not be implemented in the run method. Thread logic should not be implemented in the run method. Thread is providing only a host to run multiple methods. So where the actual logic must be written, in the methods which want to run simultaneously, but we should not write logic directly in the run method. That is absolutely wrong. Wrong implementation. Many times I found most of the others are writing the logic directly inside the run method. Either the threads want to run simultaneously or methods want to run simultaneously. Methods want to run simultaneously in different methods. But the logic written inside, generate method and print method are using some class instance variables called some JDBC connection objects or some network connection objects or some remote connection objects through which they are implementing these methods are being implemented. They are calling some network methods, remote methods, web service methods, mobile methods, different methods they'll access. They'll sometimes write it into file system. They'll generate XML documents. They'll generate JSON documents. Different things these generate and print methods, these methods will do. They will use some common objects which are declared in the number generator class, based on which these two methods implementation is written. But these two methods want to run simultaneously. For that sake, we have written two threads. So, where actually the logic must be implemented, in the methods which want to run simultaneously. Here actually the logic must be implemented, but not in the run methods. Run methods should provide only a host to call the actual methods, those who want to run simultaneously. That is one very important that everyone should remember. So, what to implement in run? Method calling. What not to implement in run method? We should not directly write the logic. Because what do you name if you implement the logic inside the run method? Can you call that logic with any method name called generate or print? No. But whereas if you write the actual logic in generate method and print method, you can call these methods as generate and print method. But the logic written in print method, how do you call that logic? With which name do you call that logic? You cannot call that method with any name. That logic is incorporated in the method. And without this thread, this method cannot run outside directly. But that is not the case how the thread should be implemented, right? First, we must write methods and then we must call the methods from the run method of the thread class. These are some of the do's and don'ts of implementing thread. And coming to the next point, coming to the client program. In the client program, we created number generator class object. Two threads are created. Into both threads, we pass number generator object and two thread objects are created. Two thread objects are created. Thread objects are created. No doubt. Thread objects are created. Thread objects are created. Now threads want to run. How threads want to run? Which method is implemented in threads? A run method is implemented in threads. In this thread also run method. So once we start the thread, the run method of generate thread class, the run method of print thread class, these two methods must run simultaneously. How these two methods will run simultaneously? How these run methods are called? We should not directly call generate thread dot run method. We should not do that mistake. We should not directly call print thread dot run. What happens if you call? Many students ask, or many developers ask, what happens if I call thread object dot run method directly? Because run method is present in the thread class, I can call run method. But if you call directly run method on any thread class, the method will run as an individual method. But that run method doesn't participate as a run method in multithreading. 100%. Then the run method can be called, but run method will run as a normal method. Run method will run as a normal method, but it will not run as a thread. 100%. After creation of the thread object, in thread one method is given name called a start. On generate thread we are calling start method. On print thread we are calling start method. On each thread when we call start method, in JVM internally one thread scheduler named one process runs. Thread scheduler named one process runs. On each thread when we call start method, immediately all the threads are registered in the thread scheduler. And the generate thread and print thread are now under the start method called on thread class will register each thread into thread scheduler first. Now this thread scheduler is having responsibility to call a run method on each method in a simultaneous manner. First to this, next 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 to this, like that. In 0.05 or some milliseconds of difference gap. The thread scheduler will allocate how much time is required for each thread to run. Based on that, thread scheduler will context switch the control from one method to another method to the next method to next method, like that and so on. This is how thread scheduling takes place. The time varies depends on your processor load and your operating system load. The amount of time allocated to the JVM. From the JVM, the time allocated to the thread scheduler will run the run methods. But remember, don't call run method directly on any thread class. The start method called on thread object will register these threads in the thread scheduler. Thread scheduler is responsible to call the run method on the thread classes, but we should not directly call run method. So that is about how to implement thread by extending from thread class. And this is having some limitations. And if you extend from thread class, what limitations we are having? Now, from the object-oriented programmer, from my perspective, I feel like what type of inheritance that Java supports? Java supports multi-level inheritance. Java supports multi-level inheritance. Multi-level inheritance means a class can extend from only one class at a time. That means once if a class extends from thread, this class will lose the chance of extending from one more class. Because Java supports multi-level inheritance, if class extends from thread, this class, the class which is extending from thread, that class will lose a chance of extending from one more class. For example, in graphical user interface applications, in graphical user interface applications, we write a login form or login frame or registration form in Java, in graphical user interface programming. We like login form, a registration form, or menu page. Whenever we write, we extend our class from frame. 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 From frame class, we'll extend from, so that we'll get a rectangular screen. On that, we'll place some menus, we'll place some forms. In that, we want to incorporate some multithreading logic also. Multithreading logic. Already the application is an user interface application, which is already extended from frame class. And here we want to implement thread. So, extending from thread class do you choose, or implementing from runnable interface do you choose? Because the class already extended from frame, the class cannot extend from thread anymore. But whereas if this form want to implement a thread, if you implement from runnable interface, on one hand, you had a graphical user interface ability, and as well as you got multithreading ability both at a time on your class. If not, in this class, you can implement this runnable as an anonymous class also, you can implement thread. That's not a big problem. But extending from thread limits your class not to extend from any other classes whose functionalities are primary functionality and multithreading functionality want to be a extended functionality, then suggested way is not by extending from thread. Implementing from runnable interface, extend from class, which is your primary requirement, primary logic, primary requirement, and implement from thread, that is your secondary requirement. That is how you decide whether to extend from thread class, or implementing from runnable interface, or implement runnable as an anonymous class object. But in all the threads, remember, we must override run method. From there, we need to call simultaneous methods. That is briefly about this entire, this slide explanation. And second one is, in the next topic, we will see how to implement thread by implementing from runnable interface, and as well as implementing an anonymous class. After completion of these extending from thread and anonymous classes, we are having some more applications on controlling the threads, wait and notify. We call them as synchronous execution. This is simultaneous execution. Sequential is completed, simultaneous execution is completed. Simultaneous execution limitations I'll explain, and then I'll go to sequential execution. Still implementing from runnable interface is left, anonymous class implementation is left, then controlling the threads by synchronizing thread implementation. That also we'll discuss in the next session, next topic. Okay, until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.